Welcome back, everybody, um, and welcome to lesson 2 of making animation with characters like Steve from Minecraft and um, a character from your choice. So Steve is just like a special one that we used for the sprite, and then for Pinky, I showed you another way. But you can actually use a few different types of characters for your animation. I'm just using Steve and Pinky as an example. So, um, I forgot to run the what we had last time where we did the animations 1 and 2 where we had the turning and jumping. Uh, yeah, you can learn from these animations how to do your animations too. So, um, the arms that goes BP other data. BPS character rig, and oh, that's because well, I didn't I reopened Blender. I didn't append in my models yet. So let's do that now. And then oh yeah, I have to delete the cube. So it's very laggy. And then let's append in the okay, fine. The other one. Mesh 0. Okay. Now this should work. Yep. And you can see they're already starting the animation. You can see Pinky is jumping like what I animated, and then they're turning like what we animated, what I animated. So yeah, these are the results for the code we coded. However, since I said I wanted to create the YouTube short I posted a while back, um, we're still not done yet, and we need to still make animation 3. So if we look at the shorts, after they turn, Steve, um, his mouth begins to start being happy, and then his arms start going up in waterfalls, and then they, then he becomes sad, and his arms droop. So pretty funny. Uh, it's a goofy animation. Okay, now let's go. So move, start, eyes. So you want to define, figure out which parts you want to, which frames you want to animate, and put them into variables. So I'm making these so that, well, its eyes, I think, yeah, Steve's eyes start to widen. So 90 and then end 50. Then move start arms at 150. Move end arms at 210. So between frame 150 and 210, he does the arm thing in the shorts where he lifts both of his arms, and obviously he starts smiling and stuff, but we will code that later in. In 92 150 his eyes start opening up. So at first, no move. So we're going to code them not moving. And now we're gonna have a long series of code. So not brilliant. But they also with key underscore bone underscore, and then it's either scale, or location. So since we're first starting with the eyes getting wider, we're gonna scale it because it gets wider. Then the first parameter inside the parentheses is pupil dot L 111 frame equals move start eyes. So pupil.L is like a part in the bone. If you open it, if you keep opening the rig, you'll be able to find it. However, I'm not going to do that now. So pupil.L left shoulder. Now, you can see frame move start eyes is this thing. Is the frame, and then we have 1, 1, and 1. So basically just telling it to stay in place and don't do anything just yet. And we can copy this except turn L into R. Yeah. Now copy this again, but replace this part where it says scale, rotation, and turn people into top arm, no underscore. Move start arms is where the frame it starts, and also replace all these ones with zeros, because in scaling is different than this rotation. In scaling the ones telling it to stay in place, and then rotation 0. So yeah, this is how you code scaling and rotation and stuff. You always want to keep them at you always want to code them like staying still at first. So top arm, bottom arm, hand. And R. So those three things. And next we do top arm, bottom arm, hand again. Oops. That's so we can copy this whole thing. Top arm, bottom arm, and then hand. Except they're all L. Okay, and then finally we're gonna code the mouth going, the mouth staying still, which is going to have two different parts. So first is the rotation of the mouth, where we just replace this with mouth. Mouth is what it's called in the mesh thing. 0, 0, 0, because it's rotation, and then move start arms is when, so we don't have mouths over here because the mouth movement matches up with the eyes and arm movement. Next is keybone location, which is actually going to match up with the eye movement. So its location is going to move before its arms do. And eyes, not eye. Yeah. Alright, now let's animate the pupils getting wider. So we can show you how, so I can show you how to code the scaling. It's straightforward. Pupil L dot R and dot L, and then you change whatever dimensions you want. So I'm gonna make them go larger by 1.5, and obviously because it's that and so those are the frames you want it. So it stays still, and then it dilates by 1.5 all the way from frame 90 to 150. Now raising the arms. This is going to be a bit more work. I mean, a bit more typing, not more work. So first things first, let's just change the frames to say the right thing instead of start end. Move and arms and alright. Now that they've all changed it, and now I can change these parts, which were 0 because nothing changed, but now we changed them because we're going to animate. And also top arm, we're going to rotate the x-axis only by negative 90 radians. So let's do that. Well, for me it's negative 90 radians. And what that does is, well, you'll see that if this is Steve, and then it's facing, I think it's facing this way. The top of the top arm, which is this part, you can see the arm is split into two parts. The top arm will rotate in the x-axis by negative 90 radians. And I'll actually make the bottom part rotate, not the same, but negative 20 instead of negative 90. And for the hand, we're actually only going to rotate the Z by 40. You can see the hand, you can kind of see the hand at the bottom. Yeah, so that way we get a smooth rotation for all these arms for 90 degrees up. Or like how much it rotates in the shorts I made. So yeah, you'll have to be careful with this. You can test it out a while to get yours to be perfect. Okay, and let's copy this and do the same thing for this. 40 radians over here. Alright. Now we've gotten the arm raising part. Now let's finally go to the mouth. So first, let's do the part where she opens its mouth. Open mouth. Key bone location. Because we're actually using the location to open the mouth. Mouth. It's gonna move very slightly. Move and eyes. By the time the eyes end, the mouth is just gonna be open using the coordinate things. Now we animate the mouth kind of opening. So, and we're using a rotation for this, so if you want your Steve mouth to smile, this is how you do it. So rotation, and so then obviously things here are gonna be, they're gonna change. So 0, 0, and the y, only the y part is going to. So 20 degrees, 20 radians is the best part. We've experimented with it, and we posted it on new shorts again. So 20 degrees radians is the best for smiling, and then it's gonna move start arms plus 30. So 30 frames after the arms start to move, it smiles. So if you play it, then it will look like it's kind of what you call it? Opening its mouth and moving its arms at the same time. Now for not happy, just stop a negative sign on here and then change the frame to wherever you want. I'm changing mine to move and arms. Alright, so if this runs smoothly, you can already see, look, it's not happy. It's opening its mouth and becoming happy, and then so you'll see, you'll think this is kind of weird, but there's, if you look at the short, there's going to be water pouring down, so it'll hide the fact that Steve's mouth becomes unhappy very early. So yeah, and you can see pretty clearly the difference between the top and bottom arm. Yep, you can see that's the kind of thing I was going for when I was coding the animation. You can test out different radians if you want, but that's just how I did it. Alright, now I'm going to teach you how to animate water. So first things we need to do, animation for water. We have to have a fluid domain, right? If you watch my previous videos, you'll know that you will need a fluid domain in order to code water easily. So let's do that. bpy.ops.mesh. We're gonna add a cube, and that's gonna be our fluid domain. Size 6. Location is 0, 0, 3. So it's the z-axis is 3, which means it's above ground, right? Which is what we want, because we want the water to come flowing down. Right now, let's set the final variable domain equals bpy.context.active object. So we're giving our cube the name domain for Blender, for Python, and then Blender, it's going to be known as fluid domain because it's a fluid domain. So DM is, it stands for domain modifier. Domain.modifiers.new fluid. So it's a fluid domain, and yeah, we just added fluid modifier to our domain, which is this cube. So yeah, now it's a fluid. Well, it's not a domain yet. We're gonna do it on this line where put domain, but these two lines combined makes it so that it's a fluid domain. Now we have DS, domain settings, way to mess with it a bit to figure out some stuff, which is domain modifiers dot domain settings. So yeah, when you type DS, then it automatically knows what going to domain modifiers, which is the modifiers in the settings. So we don't have to type domain modifier settings. Yeah, much easier. DS dot domain type is liquid, so it knows liquid water is gonna be here. DS dot resolution max is 64. To the resolution. Then use mesh is true. DS dot catch frame start equals move start eyes plus 1. So 1 frame after this move plus eyes start, then the domain's going to be active, and then it's going to be inactive at frame 300 is where approximately my animation is going to end. For your animation, you just edit this based on how long it is, and then I misspoke. Alright, now suppose you want like a continuous water flow, like in my short where water's like continuously pouring down instead of just like a big blob coming down. Well, continuous water. You just use speed vectors to true. That'll make it so that it flows down instead of coming down like a big blob. So now that we have the domain, we have to make the water material. After the water material, we make the keyframes. Then the water source, where it's going to come down. All customizable by you. But I'll show you how to do it. Water material. So first, mat is bpy.data.materials.new water mat.use nodes is true. So we have this beeps with the data. First use nodes, right? We want to give it texture blue, like blue water coming down, not like gray slop. And then we have mat, just new water. Right. Now we give it the texture because we already made the material BSDF equals mat.node tree.nodes print subhold BSDF. Alright, stuff we did in past models, changing the settings, using principled BSDF, those kinds of things. Default value is 0.2, 0.401, so that's just a blue and it's not transparent one. I think that's what it is. Yeah, it's not transparent because we want to hide the unusual part where Steve he becomes frowning early. Alright, now bsdf.inputs transmission weight. The default value is 1, so like the weight of the transmission. The append matte. So transmission width, how much light is allowed to pass in through the material. So then we append matte, and alright, now keyframes. Okay, hidden before the simulation start. Domain dot hide render is true. We want to hide it, of course, because we don't want like a giant blob of water in the animation without where the water isn't part of the animation yet. And then beta path hide render frame 1. Okay, now visible when the simulation starts. Domain dot hide render equals false, so it shows, and the data path hide render obviously, and the frame is just move start arms plus 20 frames after the frames start moving. So the perfect timing there. Steve's arms just started to move, so like around this point, like a few frames before Steve starts becoming sad, that's when it comes down. Alright, final thing for this. We need a water source, right? How is it supposed to flow down when there's no source? So let's build a water source. And it needs to be inside of the fluid domain. So before the offstop mesh, our primitive UV sphere add. Radius is 0.5, location is 0, 0, 5. So we are adding a sphere, and we're calling it blob. Okay, it's gonna be called blob. And then, but Blender is gonna know blob as water blob. Blender's gonna call it water blob, but we're gonna call it blob because we're using Python. Anyway, in the variable it's called blob. So now let's give blob a location. Where the location is just gonna be location. It's gonna be right on top of Steve. So for the X and Y, it's gonna be the same because it's right on top of it. So you know, it's not like to the side or anything. So FM fluid modifier is blob dot modifiers dot new. Name is fluid flow. Type is fluid. So we're telling it that blob is a fluid flow that flows fluids out, type fluid. So water is gonna like come down from the source, and then fluid type is flow, so it knows that's gonna flow down. And fluid needs to be all caps. Now, we're gonna have flow settings. FS. Alright. FS.flow type liquid. FS.flow behavior inflow. FS dot use inflow false. FS dot keyframe insert use, and then yeah, we're making it so that We're starting to animate the fluid coming down. So at first use some flows false because we don't want it to flow down in the beginning, that would be weird. And the settings is just liquid and inflow flowing in and it's liquid. Yeah, self-explanatory. Alright, now use inflow is true, so it starts flowing. When does it start flowing? Well, the frame where it starts flowing is move start arms plus 20. 20 frames after its arms start moving. Like what we did over here. The domain stops hiding when at the same time the water starts flowing. So yeah, that's perfect. The use inflow equals false. fs.keyframe insert use inflow. So after 10 frames, it's going to be 30. So after 10 frames, it's gonna stop. I mean, all right. So now we have the water coming down on top of Steve's head. However, there's still a problem. We don't want the water to pass through Steve. We want Steve to feel the pain of the water, which means the water needs to know that Steve exists. And that's what the next part is going to be. Fluid collision. So we're gonna make an for loop for this one. And bpy.data.objects. So for the objects, if it's a mesh, so this thing goes through all the objects and it checks if it's a mesh. So if it's not a mesh, then it ignores it. If it's a mesh, then go do this. Check for an armature modifier pointing at your rig. So this is my rig. It's an and we need an armature. So if you remember, armature, collection of bones. So if any dot type equals armature and dot object equals arm for m and obj dot modifiers. So if there is any armature, if the type is armature and object is arm for m in the modifiers, then name it fluid effector f equals obj dot modifiers dot get name. So dot get name is the fluid effector, so dot get fluid effector for the armature. If not f, so if like cannot if this doesn't work, then f obj dot modifiers dot new name is fluid. However, if it is f dot fluid type is effector. Actually, I think I explained this wrong. Alright, so f is actually, wait. Oh, so f is, I explained it wrong, I read this wrong. So modifiers.get name is just check all the modifiers and see if its name is fluid effector. okay? So it's check exclude effector as a modifier, and it's just checking to see if all of the modifiers to find the right one. And if the fluid modifier is not F, then we just give it the, I mean, no, not if you can't find, if there's no such thing as, a modifier that fluid effector, then we just create one. So yeah, to recap, this just checks if the mesh belongs to Steve by sticking the armature and the object, and then we just name modifiers, get the modifier. If it doesn't exist yet, create a new one. So now fluid type effector f dot effector settings dot effector type is collision. So making sure that it collides with Steve, so that it just so that Steve doesn't get the water passed through its body. So then we do f right effector settings surface distance is 2 times domain dimensions dot xd is that resolution max. So when we do the collision thing, there's always going to be a small gap. That's why you do it. And we want this gap to be as small as possible, right? So that it doesn't look weird. And this is just how we do it. However, you may notice and ask me, why don't you just make it 0? That's like the closest gap, right? No. Yeah, well, it is the closest gap, but it will look pretty weird on Steve. So we want to have the best gap thing, not the best gap distance where it doesn't look weird, but still as close as possible. So yeah, it's this. This is the equation. Alright, next, let's use our angle camera define function we made to create, to help shoot kind of with the camera. Focus on some parts of the camera of your animation. So first, camera position and angles, we have to define that. So this, you can just play around with it until you find the correct one. However, I already found my correct one. So to -14 what? That's position 1 of my angle. Alright, so that's the position I want. Use a vector to figure out, to tell Blender your position. And then we have names as a list, BPS character rig, so that's Steve, and then mesh 0, that's Pinky. So I'm gonna focus on both of them with this vector, which is 2x, so I think it's like between both of them, and then -14, so that means we zoom out, and then 1 is just like slightly above them, and then we need to focus on them, so that's why we have names and rotation 1, the angle camera thing, the define function, position 1 and the names. rotation 1 is like the first rotation position. Like this finds the best rotation based on the position and the things you want to focus on. Now, first position and rotation. So move camera, that thing we defined, and position 1, rotation 1. And now something you may find weird is, what's this for? Well, if you remember when I defined the move camera thing, we made a list of tuples. Keyframe is a list of tuples over here. And that's why we have the regular quotation marks, then the brackets for a list, and then the inner parentheses, not quotation marks, for the tuples. So move camera again, turn start, -1, position 1, rotation 1. Alright. So okay, so the first position rotation, so position rotation 1 until the turn starts. Okay, so that's just turn start 1 is the keyframe, I believe. Yes, it's the keyframe. So yeah, the keyframe. So it starts off looking at them 1, and then right before they turn, and we do that. And when they turn, I'm gonna focus on pinky. So position 2 is pinky dot location plus vector. So like to get pinky's location, then add a vector to capture them turning. Well, it turning. Because you may notice that when Steve turns, it's a bit weird. You may not want to show that when in your animation. However, Pinky looks more lively, so that's why the vector is just looking at Pinky from over here and then looking down at it like that. Then rotation is just angle camera, position 2, and the name is just mesh 0, which is Pinky. Yeah, because we need it to focus on that. Is it low? Okay, it's 0. Okay. Now, let's do move camera, the tuple list thing, and then position 2, rotation 2. So, right now I'm just defining some places I want to move my camera at. And you can just put on the vectors, rotations, positions, and see what you want. And also make sure you know, like, when to change. Move start eyes, -1, position 2, rotation 2. Position 2, rotation 2. This is the final frame, so one frame before Steve's eyes start dilating, it changes. Alright, now time for position 3 and rotation 3. So position 3 is armature dot location plus vector 202. Head bone armature dot pose dot bones. So we want to capture its head. So that's why we'll get the head and then the head position. The matrix arm dot matrix world at head bone dot head tail position equals armature dot matrix world at head bone dot tail. These are just how to get the head and tail positions of the head. If you look, you can see that it's split into two positions. So it's hard for me to pick them out, but they exist, and you want to pick them out. And now you want the center B of them. To get that, you just get the head position and the tail position, and then times 0.5 to get the middle part. And then that's how you get rotation 3. Center B minus position 3 dot 2 track word negative Z negative Y dot 2 Euler. And there's not supposed to, it's a 3. I accidentally press shift, and because there needs to be this and then do track word, there's this. So center B at position 3. 2 track chord. So we get center B, so the center minus the position 3. Then we just track it negative Z in the Y position 2 Euler to get the good angle. Now we can just move the camera. Move start eyes position 3 rotation 3. Move camera, and then when the arms start moving, right before the arms start moving, you want to switch the position again for my animation, and then left whole body. And this is the last part of my thing. It's just arm dot location plus vector 5 0 and 2. So like spread out more 0 2 so you can witness Steve getting dunked in water. I mean water dunking in Steve, I guess. And then the rotation stay the same though. And then we can do the final move camera. And the rotation 3A. Alright, last thing to do is just render. That context, that scene. The frame start is 1. Frame end is 240. So we just take the scene and then we tell it the frame start and end. Oopsies. Then location 0 0. Perhaps I forgot a comma. Where? Oh, I didn't forget a comma. I forgot a parentheses, and then that's fixed. But then I forgot a another parentheses, and then just I forgot another parentheses. Wow, I'm really forgetting my parentheses, and again I'm forgetting my parentheses. Okay, but when I fix my parentheses, and there's another error. Domain dot modifiers dot new fluid not found. Let's let me think. Uh, New fluid. Oh, ah, capital lies everything. Alright, now, okay, not everything's fixed. Yeah, did you mean material? Okay, so I have typos, but they're easy to fix because you just run and then Python yells at you. And okay, now Python's finally happy. Go to animation and remember turn on viewport shading and then wait a while. And I still remember in the camera and when we render it, this thing isn't going to be there, but it is now because you want you to see the fluid domain. I'll hide it and make it wire. I mean, I'm not gonna hide it. I'll just make it wire. But right, not now because it's too laggy to do that. I'll get back to you when it's done. Okay, it's done, but still laggy. However, since it's only going to be a bit slow, I do it. It should be fine. Should be fine. You can see dancing, right? And then happy, and then that's the source, but you won't see it because of the camera. Clever little camera tricks. And also you don't see the water because, well, it's wire. However, it is there, as you can see in the short I posted. But that's going to be it for the animation lesson. Bye.